Binary search in Java. In computer science, binary search, also known as half-interval, logarithmic search, or binary cop. To apply binary search, array needed to be sorted. So binary search compares the value in the middle element of the array, then according to comparison result, it compares with the other half again, and eliminates the other half of the array every time until it finds the position. If it finds the number in the array, then it returns the number, or if it couldn't find it, it returns -1 according to implementation. Time complexity for binary search is log n, which is originally log 2n. 2 defines we are dividing the array 2 every time. And because of while calculating time complexities, we are removing constant, we are ended up with log n as a time complexity. Binary search is faster than linear search, and also hash tables are more efficient for searching, but binary search can be used to solve a wider range of problems. For a given array, if we want to look at element 5, first of all, we need to divide the original array to 2 parts, which including the half of the array, every array. Because of 5 includes in the first array, we keep going searching on the first array, and then we keep going dividing the array again. And then we continue to search for the first array again. Then we are keep splitting the array 2 parts, and then we find it in the second array. As a return value, we are returning 2 because it describes the index of it. So let's look at some animation in binary search. First of all, we are defining the ending and the beginning points, and we are defining the middle point. We are looking for if our element is lower than the middle point, we keep going searching in the first one. Then we splitting the array and looking for the comparing the element with the middle element. Then we keep going splitting until we find it. So in this animation, we are finding it in the 8th position. Let's give another example which is not included in the array. It's still keep going dividing the array. Because our number is bigger than any number that we compare, we are always looking for the second array, searching for it, and we are keep dividing the array and searching for it. And it's not equal none of the numbers, so we can just basically return -1 as a result. Let's continue with the implementation. First of all, I'm going to write some tests. I'm going to implement it in a recursion way, in an iterative way. And I'm going to create the class in the main class and the methods for binary search recursion and binary search iteration. Let's start the implementation of recursion method. As some of you know, while we are implementing recursion, it is commonly needed to writing some helper methods and accomplishing the recursion in this helper method. It's a common practice. I'm giving the arrays beginning and end point and the item that I'm looking for better describing, I'm writing it as left and right, an item. If left is bigger than right, then we can basically return -1. It's an edge case implementation. If it's not, we keep going, defining the pivots. Pivots describes the middle point of the array. We can simply define it by subtracting the left element from the right element and adding the left element to the result. If the item equals to the pivot element, we just simply return it. And if the item is smaller and larger than the pivot element, we can define searching on the related array. If item is smaller than pivot, we can basically look for the first array, and if it's larger than the pivot element, we can simply keep searching in the second array. For binary search iteration implementation, we can define it item, the search elements. We need to define the indexes, with left is described as 0 and right is described the length of the array. And we go through with the while loop rather than recursion. We keep going, defining the pivot while traversing in the while loop every time. The method that we define pivot is the same as we do in recursion method. If element is equal to pivot, we simply can return pivot element. If pivot element is smaller than the item, then we keep going searching on the right element. And we are defining the left one as the pivot +1. If the element is in the first array, we can define the right element as pivot -1. And if we can't find the element, we can just simply return -1. Let's run some tests. And it works. Thanks for watching. See you in the next video.